Hello, my dear students of third prep. Today we are going to have an algebra new lesson, which is the variation. First of all, what are the types of variation? You have two types of variation, the direct variation and the inverse variation. What is direct variation? It is the increase of two values by the same ratio. So let us start to see what is direct variation. Direct variation, if a car moves with uniform velocity v, which is 15 meters per second, and it covered the distance d in meters in a time t in seconds. And this is given by the relation d equals vt. So you have the distance equal velocity times time. And I want to drop a table which says that a relation between t and d. So when t is 1 second, 2 seconds, 3 seconds, and 4 seconds, what about the equivalent distance covered by the car? When time is 1 second, so the distance covered is 15. When the time is 2 seconds, the distance covered is 30. When time is 3 seconds, the distance covered is 45. And when the time is 4 seconds, the distance covered will be 60 meters. In this case, when you look carefully to such a table, you are going to notice a relation between what? That's correct, distance, velocity, and time. So I want you to represent graphically a relation between distance and time. So you are going to draw the two axes, d and t, and then try to draw the relation between them. When 1 second time, you are going to cover a distance, or the car going to cover a distance 15 meters. After 2 seconds, the car will cover 30 meters. After 3 seconds, 45 meters, and after 4 seconds, 60 meters. So in this case, representing graphically such a relation will be like that in front of you. It will be a straight line passing through the origin as given in front of you. And in this case, we say that the increase in the time is equivalent to an increase in the distance. So this is going to be a direct relation. So the direct relation is the increase in distance and time, or the decrease in both of them. So let us see what's the meaning of direct relation or direct variation and how to represent it. If y varies x, it means that there is a direct variation between y and x. Then we can say that y equals constant, which is m times x. So when you have a direct variation between y and x, you can exchange the various form to be equal to equals constant. So we can say that y equals mx, where m is a constant, and this constant is not equal to 0. Then, if the variable x takes the values x1 and x2, and the variable y takes the values y1 and y2, then you are going to deduce a very important relation which says that x1 over x2 equals y1 over y2. It means that the ratio between the values of x, which are x1 ratio x2, is equal to the ratio between the two values of y, which are y1 over y2. Now let us have some examples informing the meaning of direct variation. If y varies x, y equals 10 when x equals 5, find first the relation between x and y, and second, the value of x when y equals 20. At the very beginning, we can exchange, yes, the varies form into equals constant. So y varies x, we can say that y varies x, then y equals mx. And in this case, by substituting for the values of y, which is equal to 10, and the value of x as 5, then instead of y we write 10 equals m times, instead of x we write 5. You have a multiplication relation, m times 5 equals 10. Can you now find the value of m? Of course, yes. By dividing both sides of the equation by 5, you are going to obtain a value for m as 10 divided 5 equals 2. So m equals 2. By taking the value of m equals 2 and substituting by it in the relation y equals mx, so instead of m we write 2, then y equals 2x. Y equals 2x is called the relation between x and y. So now we have got the first required, which is relation between x and y. Then, to find the value of, very good, to find the value of x, so it is x1 over x2 equals y1 over y2. Then, yes, by substituting, the value of x1 is 5 when y1 equals 10. And I want you to find the value of x2 when y2 equals 20. So 5 over x2 equals 10 over 20. To find the value of x2, we can make the cross multiplication you have studied before. So x2 equals, that's correct, 5 times 20 over 10. To obtain a result as 10, which is the value of x2. Now, what about the inverse variation? Inverse variation, it is an increase equivalent to a decrease with a constant value. So, we are going to have an example to show the meaning of inverse variation. If area of rectangle is m and one of its dimensions is x and the other dimension is y. So you have a rectangle, its dimensions are x and y, and its area is m. Then write a relation between m, x, and y. What about area of rectangle? All of you know that area of rectangle is length times width. So we can symbolize area of rectangle as m as shown in the example. So m equals the product of the dimensions of the rectangle, which is x multiplied by y. Then here we can say that m equals xy, as area equals length times width. If area of rectangle is 30 centimeters squared, so I want you to find the value of the missing numbers in the table. If you have a table, values of x are 3, 5, 6, and 10, and I want you to find the values of y. All of you know that area of rectangle is length times width. So we can say that to find the values of y, yes, that's correct. The first value of x is 3. One of the dimensions is 3. What about the other dimension? Their product must be equal 30. One of them is 3, so the other is 30 divided 3 to obtain a value as 10. so the other dimension will be 10. Then, when x equals 5, one of the dimensions is 5. What about the other dimension? You know that the area is x times y. So, what about the number which is multiplied by 5 give 30? Yes, we are going to divide. So, 30 divided 5, we are going to obtain the other dimension as 6. If one of the dimensions is 6, yes, their product is 30. To find the other dimension, it is 30 divided 6 to obtain a result as 5. And finally, when one of the dimensions is 10, you are going to notice that the other dimension will be 3, because 3 times 10 equals 30. Now, you are going to notice that the product of each two dimensions, 3 by 10 equals 30, 5 by 6 equals 30, and so on. Now we have got the relation between x and y, and it is represented graphically by the opposite figure. You are going to notice that it is a line which doesn't pass through the origin. Then you are going to notice that find the relation between x and y. Yes, you have obtained the relation x between x and y as x times y equals 30. And this is called the relation between x and y. It can be written in the other form by putting the y in one side. So we are going to say that y equals 30 divided by x, which is 30 over x. What do you notice? You are going to notice that y equals 30 divided by x. So this relation is called inverse variation. It's called what? Inverse variation. Because in the previous direct variation, we have studied that y equals m times x. So it is direct variation. When it is y equals m over x, it is called inverse variation. And it is written as y varies 1 over x. We can say that it is y varies 1 over x, and it can be said that it is y varies inversely with x. If you are going to state varies inversely, so it is with x. If you are not going to state varies inversely, you can say that y varies 1 over x. Both are correct. Then you are going to notice that y equals m over x. And here in this case, we can say that m is not equal 0. If the variable x takes the values x1 and x2, and the variable y takes the values y1 and y2. What about the inverse variation? Yes, that's correct. You are going to notice that y varies inversely with x. So in this case, we can say that x1 over x2 equals y2 over y1. And this is opposite to what we have taken in the direct variation. In the direct variation, we say x1 over x2 equals y1 over y2. But in the inverse variation, we say x1 over x2 equals y2 over y1. Let us have some examples. If you look to such two graphs, the first graph shows the direct variation, as the increase of t is equivalent to an increase in the distance. The other graph shows inverse variation, as the increase of x is equivalent to a decrease in y. Now, let us have some examples on variation. If y varies 1 over x, or if y varies inversely with x. Y equals 3 when x equals 2. Find First, the relation between x and y, and second, the value of y when x equals 8. At the very beginning, we are going to start by the given y varies 1 over x. Yes, instead of varies, we can write y equals m over x. And then by substituting by the values of x and y as 2 and 3, so 3 equals m over 2. By making cross multiplication, you are going to obtain a result for m as, that's correct, 6. And then y equals, by substituting, 6 over x. And this is called a relation between x and y. Then to find the value of y, we are going to use the rule x1 over x2 equals y2 over y1, as it is inverse variation. So by substituting for the values of x and y, we are going to notice that x1 is 2, x2 is 8. So 2 over 8 equals y2, which is required, over y1, which is 3. Then by making cross multiplication, you are going to find the value of y2 as 3 times 2 over 8 to obtain a result as 0.75. Another example, if the relation between the velocity v in meters per second and time t in seconds is v equals 9.8 t, determine the kind of variation between v and t. And then find the value of v when t equals 2 seconds and the value of t when v equals 24.5 meters per second. At the very beginning, what about the relation? What about the relation between v and t? That's correct. v equals 9.8 t. Then by substituting, you are going to notice that v equals mt, of course. So in this case, we can say that this variation is direct variation. Then v varies t. We can substitute, so v equals, that's correct, v equals 9.8 times 2 equals 19.6 meters per second. And here we got the velocity when the time equals 2 seconds. Then what about the time taken when the velocity is 24.5 meters per second? That's correct. By substituting, 24.5 equals 9.8 times time. By dividing both parts of the equation by 9.8, so you are going to notice that time is 24.5 divided 9.8 to obtain a result as 2.5 seconds. Let us have another example. If the height of right circular cylinder with a constant volume is h and it varies inversely with the square of its radius r, then if the height is 27 centimeters when its radius is 10.5 centimeters, find the height of the cylinder, of course, when the radius is 15.75 centimeters. In such problems, the easiest method to solve such an example is the second rule. This variation is inverse variation. So we are going to notice that the height is varying inversely with the square of the radius. So we can say that h varies inversely with the square of the radius. So h varies with 1 over the square of the radius, which is r to the power of 2. In this case, it is inverse variation. So we can say that h1 over h2 equals r2 to the power of 2 over r1 to the power of 2. by substituting for the values of the height and the equivalent radius. So, and by substituting, h1 is 27 over h2, we want to find it, equals r2, which is 15.75 all to the power of 2, over the other radius 10.5 all to the power of 2. By making cross multiplication to find the value of h, so h equal 27 times 10.5 to the power of 2 over 15.75 all to the power of 2 to obtain a result as 12 centimeters. So we can say that the height is 12 centimeters. Another example. Which of the following represents direct variation? I will give you 3 or 4 choices, and I want you to choose which of them will be representing direct variation. The first one is xy equals 3. The second, x equals 2 over y. The third is x over 2 equals y over 3. And the last choice is y equals x plus 4. First of all, when you think in such a problem, you are going to notice that 4 is dismissed, as we have never said that variation equals y equals x plus. So this is going to be dismissed. Look carefully to the other 3 choices. Direct variation means y equals mx. So when you look to the first choice, y equals, yes, 3 over x. So this is inverse variation. It is dismissed. Then x equals 2 over y. Yes, it is also inverse variation, so it is dismissed. The only correct answer is 3. So we can say that x over 2 equals y over 3 is the correct choice. Another example. Which of the following represents direct variation? The first graph, the second, the third, or the fourth. You have 4 graphs. Which of them represents direct variation? Yes, of course, we have said before that direct variation is represented graphically by a straight line passing through the origin. So, choice 3 and 4 are dismissed. They are not passing through the origin. Look carefully at 1 and 2. Both of them passes through the origin. So which of them is the correct one? It is the second one. Why? Because the increase in the x is equivalent to an increase in y. But in choice 1, the increase of x is equivalent to decrease in y. So we can say that the second graph is the one which represents direct variation. Show which of the following tables represent direct variation and which represents inverse variation. If you have a table like that shown in front of you, x and y, values of x are 3, 4, 5, and 6. Values of y are 20, 15, 12, and 10. You are going to notice that when you multiply x by y, 3 by 20 equals 60. 4 by 15 equals 60. 5 by 12 equals 60. 6 by 10 equals 60. So we can say that x times y is a constant number. And in this case, we can say xy equals 60. Then y equals 60 over x. And in this case, we can say that y varies inversely with x. And we can say that this variation is inverse variation. Another example. In the table in front of you, you have values of x, equivalent values for y. You are going to notice that the increase in the x is equivalent to a decrease in y. And also there is a constant value when dividing y divided by x. Look, 9 divided by 2 equals 4.5. 18 divided 4 equals 4.5. 54 divided 12 equals 4.5. And finally, 72 divided 16 equals 4.5. And in this case, we can say that y equals mx. as y varies directly with x. And in this case, we can say that this variation is direct variation. By the end of this example, we have reached the end of our lesson today. I wish that all of you understood the lesson, and I want you to try to solve more and more examples from your school book. Thank you for good listening, and bye-bye.